Hi, everybody. This is lecture 8.1. So we'll have two lectures for this particular week, and this will be covering epidemiology and infection. So with that, I'm going to move to my PowerPoint and get us started. So for this particular chapter, we're really looking at what is called viral epidemiology. And this is of particular interest to me because after my graduate work, I actually worked in epidemiology. So if you're somebody who loves mysteries or solving puzzles, and you're also interested in science, then epidemiology should be incredibly interesting to you. So in this particular mini lecture, I will be talking about what epidemiology is. I will also talk to you about the steps of infection from the host's point of view. So if we're thinking of ourselves, what we would experience if we were infected by a virus. So the common cold is probably the most easy to explain because most of us have had experience with it. There is a lot of vocabulary with this. So for this particular chapter, it may be a good idea to make some flashcards to get through all of these. So the vocabulary I have listed below, but each of these terms I will actually go through as we walk through the lecture. So first, we're going to talk about what epidemiology is. And epidemiology is really the study of how a disease or diseases affect whole communities. Now, those whole communities could be at a local level. So maybe we're looking at a city or perhaps a county, but they could also be looking at communities thinking of a state, country, and even worldwide. We could study how diseases affect people in those communities. The term endemic means that there's a particular disease that would persist at a steady level in a geographical area. So malaria is a good example. In much of Africa, we see that we have a steady level of that disease that is found year to year. It's very predictable. Now, there has been some talk about whether or not SARS-CoV-2 or COVID has become endemic, but at this point, because it's not at a steady level, we still have kind of these peaks or surges during the summer and winter, and they're somewhat unpredictable. It's not quite to that level. But endemic would be that we expect to see a certain percentage, a moderate percentage, stay at a steady level year to year in a geographical area. Sporadic means that we have cases or diseases that have outbreaks that have no particular pattern, but they're not very large. There is no pattern to where they occur or when. A good example for this one I would think of is Ebola virus. We see kind of these outbreaks. It might affect tens to hundreds of people, and then it kind of dies out very quickly. And we go for months to even years where we don't see cases, and that it's not something that we could actually predict. An epidemic is when we see an unusually high number of cases, so more than what we would typically expect. So for example, in January of 2020, SARS-CoV-2 or COVID-19, we saw an epidemic in China, right? So we saw it primarily in the Wuhan area of China, but at the time it was considered epidemic in that we thought of it as a region or country. Very shortly after that, it then became what is called a pandemic. And a pandemic has kind of the same definition as an epidemic, but rather than a particular region or country, it's that it has spread across continents. So it jumped from Asia into Europe and North America. And with the current pandemic we are living through, it is worldwide. SARS-CoV-2, although it may not seem as big of a deal as it might have felt 4 years ago, we would still call it a pandemic because we have unusually high numbers or surges of this. We don't really have expectations of how much we should expect, including surges during the summer, and it's still worldwide. A few more definitions. We use the terms morbidity and mortality in epidemiology. Morbidity refers to how many people have the illness or suffer from a particular disease. So we could say that the morbidity within maybe the United States, we could talk about the morbidity for HIV for a year. Basically, how many people in a year in the US have the actual disease. Mortality is looking at the deaths caused by a particular disease over a time period. So instead of saying how many people are affected by a disease, we could say how many people died from that disease in 2023 or 2024. Incidence is looking at the measurement of morbidity, basically the number of new cases that we see in a specific time period. So we might say, what was the incidence in January versus February of 2024 for people with COVID. And then we would be able to compare those two. We also have another measurement of morbidity, which is looking at the prevalence, the cases that exist in a population at a specific time. So incidence was looking at new cases kind of from time period to time period. And prevalence is basically looking at the cases that exist in a population at a given time point that we're looking at. The last vocabulary word that I have on this part is an etiological agent. And so in this case, this would be whatever pathogen or disease-causing agent is causing the disease. So because this class is on viruses, we would imagine that the etiological agents that I would be talking about would be viruses. So let's talk about these steps of infection. And I'm going to bring us all over to our whiteboard first and write these out, because I think sometimes it helps to have kind of a list of these. So if we think of a host perspective, so basically what I would feel perspective, we can break this down into 5 steps. So the first step is what we would call the incubation period. And so you can think of this incubation period as the time in which you've been exposed, maybe somebody coughed on you, sneezed near you, maybe you touched somebody who had some sort of a rash, but you don't yet have symptoms. So this period, you are exposed to the virus, but you don't have any symptoms. So, but no symptoms. Okay. The second step that we want to talk about is something called the prodromal phase or stage. And this is where the virus that you may have been exposed to in that incubation period has begun to replicate. And you're likely to start feeling symptoms, but they're not like the classical symptoms of the disease. It's more that you have this sense of unwellness. So in this case, you might feel tired, run down, just not up to 100%, but not really sick yet. So I would call these non-specific, mild symptoms. So again, this is where I always joke that in my family, when people have been sick and I know I've been exposed and I'm starting to feel a little run down, I often say, oh, I can fight this. I'm going to take care of myself, drink lots of liquids, vitamin C, and I'm not actually going to get sick. So that's the prodromal stage. The next step then is what we would call the acute phase. And this is where the virus is really replicating at its highest level. You have the most virions in your body and it's causing the most disease. And so this is where you would have all of the classical symptoms, right? Whatever that disease is, you have all those symptoms like the sore throat, the runny nose, anything like that. So that's our third step. Our fourth step is something called the period of decline. And this is actually the period of decline for the virus, meaning that the amount of virus that's replicating is beginning to decrease. And we kind of feel like we've turned the corner and our symptoms are starting to go away. So I'm going to put lessening of symptoms. So this is usually where maybe you've been sick for 2 or 3 days and all of a sudden you're starting to feel like your nose isn't as running, your energy's coming back. You're not completely symptom free, but you feel better. And then the last stage is what we would call the convalescent. And in this one, this is where if this is a virus that you can actually rid your body of, so the common cold, you actually have gotten rid of the virus. You are no longer ill. The virus has left your body. Now, if it's a latent disease, something like chickenpox that could come back as shingles, or maybe the herpes virus, this may just go into latency where we don't have any symptoms, but we haven't actually rid our body. But in this case, then we are back to no symptoms. I do want to mention that although I'm putting the 5 steps of infection, that there is some diseases where we may not get out of the acute phase, right? Some of these are so severe that some people die and never make it to that period of decline or convalescence. So it's always good to be aware of that. But again, this was the host perspective on steps of of infection. Okay, and we'll go back and go over this in my slides as well. But this hopefully gets you thinking about that, right? You can imagine that if somebody in your family is sick, you might be in the incubation period where you've been exposed to their cold, but you don't have symptoms yet. Then maybe a day or two later, you start to feel a little bit run down, but you don't have the classic symptoms. And then maybe you get that full-blown virus, like the sore throat, the runny nose, the watery eyes. That would be the acute phase. And then we turn that corner, our immune system starts to kick in. It starts to fight with the virus and starts to stop its replication. And we go through that period of decline and then convalescence. Excuse me. We'll go back and look on our chart. Oh. So in this figure, this is showing those same 5 steps. They name it the period of illness, but you can think of this as the acute phase. So we have this incubation period, and on the y-axis, you'll see it's the number of viruses we would find in the body over time. So as I said, in that incubation period, we don't have any signs or symptoms, and we really have a low level of that virus in us. Then we start to have the virus number increase, and we go through that prodromal period where we have mild signs or symptoms, but again, we don't really feel sick yet. And then we have what I would call the acute phase or period of illness. This is where we would expect to see the highest amount of the virus in the body. If the immune response or medical treatments fail, as I said, this could be the last step if somebody was to die from the infection. But with the common cold or something that's less severe, we would expect to see them go through the period of decline. And at this point, you see it's a decline in the number of virus in the body. So you start feeling better to the point where we get convalescence. And ultimately, if it's a virus that you rid the body of, you no longer have the virus in you. So hopefully that helps kind of think about it, and everybody can maybe think of the last time you were sick of these different steps. So again, I put up here those steps of infection. So the incubation period, the time between infection with a virus and the onset of symptoms. So there would be no symptoms in this particular step. Then we have the prodromal period. That's the first appearance of kind of those mild or very non-specific signs and symptoms of the illness. You're feeling run down, maybe a little fatigued. Then we go to period of illness or the acute phase. This is where we have those typical symptoms with the disease. Whatever the disease is, you would be presenting with all of those ones that we would expect to see. The period of decline then is that phase when symptoms begin to subside, and that's usually because your immune system has started to respond, or maybe you've started taking antivirals, some sort of medication to treat it. The last step then is that convalescence, the recovery period after the disease, where we would generally go back to a healthy state. So I do want to go over just a little bit more of our vocabulary, kind of thinking of the transmission of viruses. We can talk about the idea of mode of transmission. How is an infectious disease spread or passed? And we'll talk about this later on in this particular week. We can talk about either direct, meaning that you had direct contact with either another human or an animal or some sort of environmental water or soil that you caught that virus from, or we could have indirect, where maybe the virus is airborne or it's on some sort of a vehicle like an intravenous needle or food or water that's contaminated. And we can also think about indirect, the idea that it could be from an insect, right? An insect bite or something that an insect carries. So we will talk about that a little bit more in the next lecture. We can also think about the communicable period, and this is the time in which the infected individual, typically we think of humans, but it could be an animal, in which they're contagious, meaning that they could actually transmit that particular virus to another person, animal, or in the case of a vector, an arthropod is an insect where it could actually bite an infected human and then move on to another human and bite them and transmit it. Then I also wanted to mention the term zoonosis. This is very much like what it sounds like, zoonosis. You want to think about an infection or infectious disease that gets transmitted from animals into humans. So you might think of like rabies as one. Most of the data on SARS-CoV-2 looks like it was likely a zoonotic disease as well, that it was likely in bats and somehow made that jump, had a mutation that allowed it to start infecting humans. And from that, we have just the last couple definitions. An infectious dose is the least amount or minimum number of those viral particles or virions that would be necessary to be transmitted from one host to another to actually be able to establish an infection and disease. So often we talk about the fact that although with SARS-CoV-2, a vaccinated person could actually get COVID and they could pass it on, they are likely to have less infectious doses. They would have a lower viral load, which means they would be less likely to infect as many people as somebody who would be unvaccinated. And then the last one is the R naught, which is the measure of the potential transmission or how many people one person could transmit to, meaning that we would expect with less transmissible or less easily or less contagious diseases, the R naught would be lower. As the R naught goes up, it means it's the number of people one individual could infect. And what we've seen with SARS-CoV-2 is that as the new variants have come about, the R naught has gone up, meaning that it's more contagious than it was when it first started. So maybe with the very first strain of SARS that we had at the very start of the pandemic, maybe one person could infect one or two people. When we got to Omicron, we were seeing that raise much higher to where it was more like 6 or 7 because they were, it was a more contagious virus. That strain was more likely to cause infection in the people around. The last thing I just wanted to briefly touch on, which I always think is an interesting story, is kind of the history of epidemiology. And this is based off of a doctor named Jon Snow, not the one from the TV show of Game of Thrones, but he was a doctor in the 1850s in London, and he was studying cholera, which was this incredibly awful disease of the gastrointestinal tract. And what he did was he tried to disprove the idea that the disease was being spread by the smell in the air, because at the time in London, it was a big city and they didn't have great sewage and infrastructure. And so it smelled really bad. And people there assumed that it was because of the smell that people were getting sick. But he believed that it was actually waterborne, this particular disease. And so what he did was, when there was a cholera outbreak in London in 1854, he actually took a map of London and showed where the pumps were, where people were getting their water from. And then he put on this map bars for people who got sick or died. And what you could see from it was that we would see clusters around particular pumps. And in this case, it was the Broad Street pump that basically told him that it definitely was the water. That was the source of these cholera deaths and not something that was in the air. And I think I have a picture of that. So this is a picture of Jon Snow, and it's showing the famous water pump. But if you look at his map, you can see that these little bar graphs show the number of deaths. And the pump was right in this area. And what you see is that all surrounding it were a lot of deaths. But as you moved further away from that water pump, we had less deaths. And this was actually the first time that the idea of being able to kind of solve the mystery of disease and then be able to say, if we have a cholera outbreak, we all must boil our water or get our water from somewhere else. It's what actually allowed big cities like London or Los Angeles to actually figure out how to function as big cities. So this was kind of the father of epidemiology, if you will. There's a great book called The Ghost Map about Jon Snow's map, talking about cholera. This isn't a disease we see a lot in the West unless we have some sort of natural disaster. But when we don't have access to clean water, it actually spreads quite quickly. So we'll finish here with the checking in. Please do pause the video and make sure to write down the answers, and then we'll go through them. Once you're ready, you can come back and start the video again. For the checking in, the first question is, what does endemic mean? Endemic means that we have a steady level of a particular disease in a particular location and that it's very predictable. What step follows the prodromal stage? I refer to it either as the acute stage or it can be the illness stage, right? What does zoonosis mean? Zoonosis means the transmission of disease from animals into human. What disease did John Snow show was transmitted by contaminated water? He showed that cholera was being transmitted through contaminated water. Thank you, and let me know if you have any questions. And there is one more lecture for this particular week. Thanks.